Alright, so here we have this question. Basically, we have to find the rotation count in rotated sorted array. So what we have to do right here is basically just find out the number of times we rotated the array, to be precise. So initially the array would have been, oh, by the way, I've been following this course of Kunal's, so it's very amazing. Back to the question. We by default we would have had the array as in 2, 3, 6, 12, 15 and 18, but as it's rotated, and right now here it's visible, it's rotated twice, so that's why it's 15 and 18. So basically we need to find out that number, the times we rotated it. So we'll start with the code part. New, it won't let me. Okay, anyways, we'll do it right here, that's fine. So yeah, we'll say so we'll have the array as it's given in the question. We'll take that after a few moments. Then basically we'll have the answer as the function that we'll be creating. So that can be, first of all, in the question, as we see, we'll be needing to find the peak. So peak is basically the element that is having the highest value. As we see right here, if we find out the peak in this question, basically we get the whole question done. So peak here in this array can be 18. Obviously that's the highest valued element. So basically we have to find out the peak, and then basically the whole question is done. Then we just need to calculate the position of that peak. So the question is basically find out the peak and then calculate the position of it and then add one with it. So we'll say answer is peak array. We'll create this right now. So yeah, private static int peak. So that will be containing the int array. So what we will be doing is that we'll be printing out this peak, but what we will do is add one in it. That's pretty visible why we're doing it, but I'll get to it in the later section. So now we have the function created. So now we'll be performing the generic binary search coding right now. So int start can be 0, int end can be add dot length -1. Now we'll be having a while loop wherein start less than equal to end, and then we'll take int mid, that is start plus end minus start divide by 2. Basically the reason why we do it like this is because we can easily do it by start plus end divide by 2, but then suppose start is a very big value, that is the most we can take, and then end is something that is having the same exact value, the biggest, but less than 10, less as compared to start. So basically what happens is that if those two values exceed the actual amount or the number of the values that we can take, so yeah, that creates an error. So we don't want that, so that's why we simplify it like that. And then we will have if. So now what we need to do is that we need to check how can we find the peak element. So basically what we will do is, considering that this is the array 15, 18, 2, 3, 6, 12, 15, 18, 2, 3, 6, 12. So basically what we have right now here is an array that is having 6 elements. So the length minus 1, that's 5. So if we find out the middle element of it, the middle index will be 2. So that will be 0, 1, 2, 2 itself. So this is the middle element that we have with us. So now let's think around this 2. So basically when we have this 2, so if we notice in the array that from 15 to 18 we have ascending order, and then from 2 to 12 we have an ascending order. So basically from 18 and 2 we have a descending order. Nowhere else in the array will be finding a descending order. So basically from 18 to 2 we have a descending order. So we'll find something around it. So if you look at 2, which is currently our middle element, so we see 2 and then the element before it, that is mid minus 1. So if mid minus 1 is greater than the middle element, then we can easily return middle minus 1, the index, and that will be true for like the any case we take, because obviously we won't be finding anywhere else it going in descending order in any sort of array if it has been rotated. So yeah, if middle is less than middle minus 1, that is 18 in this case, so we can easily return middle minus 1 index, and that's going to be the peak element for us. So if array's middle element is less than array's middle minus 1, then we can easily return middle minus 1. But we need to also see that this middle minus 1, what we are doing right here, is basically like, for example, if the middle element was 15, so we can't do middle minus 1 because we don't have anything known as minus 1 indexing. So what we need to do is we need to make sure that we don't land up in a situation wherein we have to do middle minus 1 and the middle element or the middle index is 0. So what we can do is so we always want that middle should be more than start. So we can say middle more than start, and then both the conditions should be true. So that's why we have this and. So middle greater than start and middle less than middle minus 1, that will be sufficient for us. So now moving to the next loop. So now what we'll do is, now we'll see that if suppose 18 was our middle element, so 18 plus like middle plus 1, if middle element is greater than middle plus 1, then we can return middle element, because then again descending order won't be happening anywhere else in the loop, so we are safe with it. So if array's middle element is greater than array's middle plus 1, we can return middle, no worries. But then again, this middle plus 1 condition should be taken care of at the end, because obviously you don't have anything else like 12, that's it, that's the end point. So you need to make sure that you deal with this problem. So what we can do is we can say that end should be always greater than middle, and both the conditions should be true simultaneously. So and so end should be greater than middle. So in any case, if middle is not less than end, that means it's either equal or either more than end. So that makes no sense. You don't have to apply that case. So make sure that you don't. So now we talked about two cases wherein we saw that how easy it was, because we were searching for the middle element. So we were able to deal with it by going left or right towards it, middle +1, middle -1. But now what if we don't have that case? What if our middle element is 3? So you don't have what we say, middle -1 greater than 3, because obviously that's 2. You don't have middle +1 less than 3, because obviously that's 6. It's greater than 3. So what you can do is you can have a loop wherein like you want to find the peak, the highest element. So what we see right here is that if your middle element is less than start, then you need then obviously you will need to search in the left hand side, because it could have been possible that, like for example, I'll write that down. If array start is greater than or equal to array mid. So right now what we see is that if the array's start, that here in this case it's 15, if it's greater or equal to middle element, that's 3. So what we can do is we can easily ignore this right hand side, that is 6 and 12, and look at this portion. The reason why we are ignoring the right hand side is because see, for example, if we have this array, so if 15 is greater than 3, then there is no need to look at the right hand side of 3, because we either the element is going to lie on the left hand side, because obviously we have 15 greater than 3, but the question can be 6 and 12 are also greater than 3. That's fair, but we need to understand 15 is also greater than 6 and 12. So if we have 15 right here, there is no need for us to look at the elements on the right hand side. So we can easily now ignore the right hand side and focus on the left hand side. So for that, if array start is greater or equal to the middle element, then we can just shift end and make it mid +1. So end can be mid +1. So basically now we'll be moving end from this 12 to mid +1, that's 2. So 15, between 15 and 2 now we'll be performing the search. But there can be another case wherein else we have the start element now less than 15. My bad. Exactly. Start element less than the middle one. So when you know that the start element is less than the middle element, that obviously means that now you'll have to look into the right hand side of the array. So right hand side of the middle portion. So basically start will be then middle +1. Simple. So now we have the loop complete. Now if the while loop doesn't work out, if it breaks, then yeah, -1 if we have no result. So basically now what we have right here is a while loop which is performing the operations using if else if and everything to find out the peak elements index. And right here what we have is that we are returning the answer +1. Yeah, so here we are returning whatever we found out in this peak function into the answer. We are printing that out, and now we are making sure that we do +1. The reason for +1 is that because of the arrays starting from 0, what we did was that we found out the index of the peak element using this loop, this function. So now we know that 18 lies at the first index, but what we need to find is that how many times the array was rotated. So for that we need the actual amount, that is from 1 to, not from 0 and 1. So yeah, that count starts from 1, so basically we just add 1 so we get the accurate answer, logic being the same. So if we run that, okay, my bad, we need, yeah, so if we run this, yeah, we got 2. So array has been rotated twice. That's what it is about. We can verify it by adding another element right here, 19. So now this shows that array has been rotated 3 times, thrice. So if we run that, we get 3. So yeah, that's it for the question. So yep, thank you.